Right, here we go with assessment practice number 2, and this is on the furniture factory. So I suggest you pause the video, try this, and see how you go, and then come back and check it. Okay, I presume you've tried it. So Felix works in his furniture factory. He makes bookshelves, chairs, and tables. So we know what to do by now. We are looking for totals. So we've got 1750, we've got 160 hours. There are equations 1 and 2. So the timber used is going to be these ones here. And the hours, perhaps I'll do it in a different color. The hours that you're going to do are going to be these ones here, 160 hours, and you're going to use those for your equations. Okay, we have a balance equation. He decides to make 4 times as many chairs as he makes tables, so that's our balance equation. So we're going to do task 1 first. So here we have task 1, and here's our first equation. So we've got, we've explained that we're doing books as B, bookshelves B, chairs C, tables T. So there's our first 2 equations. For the balance equation here, 4 times as many chairs as he makes tables. This is my favorite method. Do a seesaw, and after you've done your seesaw, does he make more chairs or tables? We're not talking about the weight of the tables, but it's a number. Because he makes lots of chairs, they would balance out the number of tables. So we've got to multiply the tables by 4. So you get chairs equals 4t. Then bring the t to the other side. Chairs minus 4t equals 0. And so you have it in bookshelves, chairs, tables, that order. So that's why I've got this equation there down here. That's number 3. Now put these in your fixed box. So you draw a box and we put equations 1 and 2. Equation A in there. That's A. To get equation B, we've got to take this one here, 5b, and we've got to make it equal to 50. So I'm going to do 10 times equation 2. So I've done it to the side here. So I'm going to take equation 2, I'm going to make this 50, 40, 30, 1,600. So I've done that there. Then you subtract it away because we're taking away the top equation, the bottom equation from the top. So the 50b is just going to disappear. 25 minus 40 is going to give you negative 15, 90, and 150. Just be careful with your subtraction. This here is equation C. So we write it in our fixed box, which I've done for you down there. So here we have A, B, C. Sorry, write that as equation B. That wasn't equation C, that was actually equation B. Equation C, we have to eliminate the first variable. Now note there that equation 3 has 0b already. So we just have to copy that bit in. So that's quite straightforward. That's why we've got C minus 14. So equation 3, you just copy in because you've got no b part there. Now we want the same number between here and here, so I'm going to multiply equation C by 15. So I go 15 times equation C, and then I'm going to add it together with equation B. Why do I add it? There's equation B there. Because 1 is negative, 1's positive, so when I add it together, I get 0C, 30t minus 150. This here is equation D. That's what we want, so you put that in your box there. Now we can sort out this equation, solve it by dividing by 30. And when we divide by 30, we get t equals 5. So that's 5 tables. Put 5 in equation C. I'm going to do equation C because it's less complicated than B. You'll get the same answer if you put it in equation B. So C minus 20. So I put the 5 in here 4 times the tables. 4 5s are 20. Put the 20 to the other side. Chairs equals 20. So 20 chairs. And lastly, take equation 1, or A, and we've got T is 5 for the tables. Is it bookshelves, tables? Hold on. C. C goes in here. C is 20. Almost did that wrong. And there are 5 tables. So this is the timber equation. So this makes here 500. This makes 600. Add those together to get 1100. Subtract it to the other side and you get 50b equals 650. Divide by 50 and you get b equals 13. We're almost done. We now have to put that in a sentence form. So let's write this. He makes 13 bookshelves, 20 chairs, and 5 tables. And there you have that. Draw a diagram. Oh, it's also a unique consistent solution. Consistent means you have answers. And it's like the corner of a book. Draw your Y and your three planes. That's geometrically. Now we're going to go on, that's an achieved. Now we're going to go on to the merit section. He finds that his business is growing. He starts making 6 times as many chairs. Last time it was 4 times as many, but this time he wants 6. So the 4 has to change to 6. So I've copied those equations out. And this 6 here is going to be changed to 4. And so when we copy the equation 1 and 2 are going to be the same. So equation A, equation B. But when you put equation T, it's now 6t rather than 4. Because it was 4, but it's changed to 6. And so we've got this equation. We need the same number 15, so I multiply equation C by 15 like we did before. And when I add it together, I get 0 equals 150. Now this is a false statement, so it is inconsistent. The planes intersect the lines parallel to each other. So it's inconsistent. Try and mention that word when there's no answer. And here we have like a bookshelf, so the planes meet in lines that are parallel to each other, and so there are no solutions. They never meet. So we can't do that. So let's go on to task C. He still wants to use the ratio of 6 chairs for every table. I'll just get the question there. So he wants 6 chairs for every table. He wants to use 1750 meters of timber each month, but he's going to change the number of hours. So we're going to change hours to H, and we'll have a look at his plan. So instead of having 160 here, I change it to H. Equation 1's the same. Change this to H, and we'll leave the C minus 6t because he wants the same ratio of chairs to tables. Hopefully you've got that. Now let's go ahead and do our fixed box. So equation 1's the same. Equation 2, when we sort it out, we get 1750 minus 10h. Right? So what we need to do is we need to multiply this equation 2 by 10. And have I done it over here? I haven't. But let's do it over here. So we have 50b plus 40c plus 30t equals 10h. And the top one was 50b plus 25c plus 120t equals 1750. So we're going to subtract away, and when we subtract away, we are going to get an answer that looks like this. Let's go back and we'll, oops, let's get our right pen here. This one here. 50, and we're subtracting away this whole equation. 50 minus 50 is nothing. 25 minus 40 is negative 15c. And 120 plus minus 30 is 90t. And this, instead of equaling 0 like last time, is 1750 minus 10h. So we leave it like that in terms of h being the number of hours. So that's my equation here. That's why I've got 1750 minus 10h. Equation C has no b there, so we can write that in. Now I need to multiply to get 15 in front of this one here. So I'm going to take equation C and I'm going to multiply it by 15, or equation 3 multiplied by 15. It gives us this. When we subtract it away, we get 0 equals 1750 minus 10h. Put the 10h to the other side. Change side, divide by 10. So if he increases his hours to 175 hours, he will be able to find the solution to that. So he could change the number of hours to 175. It would give multiple solutions that are consistent. And then we let t equal a particular number. let t equals n. So the number of chairs is 6 minus c minus 6n instead of 6t. So I put 6 minus c minus 6n there. So the chairs equals 6 times n. So the tables is n, and the chairs is 6 times the number of tables. Then we're going to use equation 1 and find out in terms of n what the number of bookshelves are. So we've got 50 bookshelves and 25 chairs. Now c chairs is not c anymore, but it's 6n because they're equal. And 120 tables, and tables is not t anymore, it is n. So just to expand that out, that's 150n, that comes to 270n. Subtract the 270 to the other side. Divide everything by 50. And we get the number of bookshelves is 35 minus 4n. Slow this video down if it's going too fast. We'll just pause it. So here is our solution. The number of tables we'll call n. The chairs is 6 times the number of tables, n. And the bookshelves is 35 minus 5.4n. So let's try some values. Let n equal 0. If there's 0, then the chairs will be 6 times 0, so that would be 0, and the bookshelves would be 35. So he could spend the month making no tables, no chairs, 35 bookshelves, and he'd be able to do it. But if we had n equals 5, he could make 5 tables and 30 chairs and 8 bookshelves. These are the only two integer solutions, because this number here, 5.4, has to be multiplied by n. So I knew that 5 times 4 is 20. I would get rid of that decimal there. So let's take this 35 minus 5.4n. It can't be negative. It must be greater than 0. So we shift the 5.4 to the other side. And we divide by 5.4. So n is less than 6.48. So as long as he doesn't make more than 6.5 tables, he should be able to find solutions. So there are multiple, that shouldn't be integer, that should be multiple decimal values. There are multiple decimal values when n equals less than 6.48. For example, if n equals 6, tables equals 6, chairs 6 times tables, and bookshelves would be 2.6. It is possible to make 2.6 bookshelves in a month. You just leave the rest till the next month. And then the integers, the solutions lie on a straight line, like the pages of a book. These are consistent, and there are multiple solutions. This is for excellence. We have showed our extended abstract thinking. For excellence, you need the diagram. You need a solution. You need a generalized equation. You need more than one solution. And you put everything in terms of those. That's what we're looking for the excellence, if you can interpret that. Okay, so there's a good example of how to do a question right through to excellence level.